Hi everyone, lesson 112, graphing and solving systems of linear and quadratic equations. Some of the examples you're going to see both linear and quadratic graphs on the same coordinate plane. And so when you do that, they're going to ask you to find the solution, which means where do the lines cross? So in the first example, linear with one solution. You can see that you have two linear equations that are graphed, and I have circled here where the two lines cross. So that ordered pair would be the solution to that problem. The one on the right-hand side, you have a linear and a quadratic graphed in the same coordinate plane. There's also one solution there. You can see that I have circled in green where they both cross. They only cross in one place, and that point is 1, 1. On the bottom left, you can see we have linear and quadratic, but there's two solutions. They cross in 2 points, -2 and 4, and 3 and 9. And then the very last one, the yellow, the linear and quadratic with no solution. You can see that neither graphs touch, therefore there is no solution. Let's look at an example here. Example 1a, solving by graphing. So we're going to graph each of these equations and then find out what the solution, if there's a solution to them, would be. So the first one, I'm going to use y equals x squared. So square the 0, 0, square 1 is 1, square -1, 1, square 2 is 4, square -2 is +4, square the 3, that's a 9. Over on this x one, y equals 2x. So 0 times 2 is 0. 2 times 1 is 2. 2 times a -1 is -2. 2 times 2 is 4. 2 times a -2 is a -4. 2 times 3 is 6. Now that I have everything completed here, now I just need to plot them on the graph. So each of these lines are coming by 1, so it's really 10 in all the directions. So I have a 0, 0. I have 1, 1, -1, 1, 2, 4, -2, 4, and then I have 3, 9. 3, 9 would be here. This would also be -3 and 9. So I have my parabolas here. I can draw my parabola. So there's that first graph. The second one, put a point, 0, 0, 1, 2. Actually, that's not 1, 2. 1, 2 would be up here. So let me fix this one here. Okay, then -1, -2. So -1, -2 is down here. Then I have 2, 4. So 2, 4 would be right here. Then I have -2 and -4 be down here, and then 3, 6. Now I can draw my line, connect it. You can see that it crosses in this place, in this place. I can verify on the graph. I can also see it in my table here, 0, 0, 0, 0. So that's one solution. The other solution is right here. They both have 2 and 4. So that's the best part about choosing the same x's for both equations when you do a table, because then you can see easily if there's anything that's in common with them, even before you actually graph it. The next example, I'm going to have you do this one yourself if you need extra practice. Same thing with this next problem. The second type of problem is using your graphing calculator to solve. Here you can see they graphed both of these on the calculator and showed the intersection point. But I'm going to show you right now how to do it from square one. So turn your calculator on, hit the y equals button, and you can see right now I already have everything typed in here. So x squared divided by 2 minus 3, and then x minus 3. So if I would hit graph, you can see my parabola here, and then my linear equation right there. I need to find out where they intersect. And it looks like they cross here and they cross here. So to find it, I hit the second button, trace. I want to look at the intersection point. So I get hit number 5. I'm going to go down. So the parabola, so the left-hand side, so the first curve, hit enter. The second curve is the linear line. So about here, enter, hit enter a third time. So this tells me the intersection point. When x is 0, y is -3. That's what we have right here. The next one, try it again, second, trace, hit number 5. This time I need to go further over on the parabola, so about there. Second curve, we'll say about the same spot, hit enter a third time. And it says when x is 2, y is -1, so that's the intersection point there, which that's what they had, 2, -1. So those are your two solutions for this problem. The third type of problem today is using substitution, which you've already done earlier this year. We're going to do the same thing here, but with a linear equation and a quadratic. Since they're both equaling y, I can substitute -x minus 1 in for this y. So if I have a -x minus 1, that equals x squared plus 3x plus 3. I need to make everything equal to 0. So I'm going to add x, add 1 to both sides. When I do that, that gives me 0 on the left-hand side, x squared plus 4x plus 4. And I know that's a perfect square trinomial. So 0 equals x plus 2 squared. But I know that there's only one solution here. That means when x is a -2, what is my y? So I'm going to plug my -2 into this equation right here. So a -2 minus 1 gives you a +1. So this would be my solution to this problem. It only crosses at one point, -2, 1. The next example. Here I have 4x minus 1. I'm going to substitute that in for this y. So I have 4x minus 1 equals x squared plus 2. I need to get everything to one side, so it equals 0. So I'm going to subtract 4x and add 1. Add 1 here, subtract 4x. Now I have 0 equals x squared minus 4x plus 3. I can factor now. That gives me two binomials. I know -3 times a -1 gives me a +3. -3 plus a -1 gives me a -4. So those are my two binomials, make them both equal to 0. So that tells me the two binomials are different. I have two solutions. So I need two ordered pairs. One of them, x is 3. The other one, x is a +1. So now if I do some substitution, I plug in 3 in for x. I'm going to use this one right here. So 4 times 3 minus 1 gives me 11. Put a 1 in. 4 times 1 is 4, minus 1 gives me 3. So my answer, I have two answers, 3 and 11, 1 and 3. You may do these next two problems yourself if you need extra practice. An example 4a, using application. Two arrows fired at the same position can be respectively modeled by y equals -x squared over 1600 plus 2x and y equals -x squared over 400 plus 6x, where x is the horizontal distance and y is the vertical distance. At what approximate altitude, so we're talking about vertical distance, will their two paths cross? So you can do this two ways. You can use substitution, or you can use your graphing calculator to solve this one. Just to show you how do you do it on paper, if you didn't have a graphing calculator, I'm going to use substitution here. So since they both equal y, I have a -x squared over 1600 plus 2x this has to equal a negative x squared over 400 plus 6x. I want to get rid of my fractions. So I need to multiply by a common denominator. So 1600 would be the common denominator. Get rid of all my denominators. So 1600 divided by 1600 is 1. So that just gives me a negative x squared plus 2x times 1600 is 3200x. 400 and 1600, that just gives me 4. 4 times a negative x squared is a negative 4x squared. And then 1600 times 6x gives me 9600x. Now I need to get everything to one side, so I'm going to bring everything to the left. So I need to add 4x squared. Subtract 9600x. So add 4x squared, subtract 9600x on both sides. That gives me 0 here. That gives me 3x squared minus 6400x there. And I can do some factoring. I can take out an x in both places. That gives me 3x minus 6400. This equals 0. I don't need to worry about the x on the outside because that could be 0. I want to find out what does x have to be in the parentheses so it equals 0. So if I take 3x and I need to add 6400 to both sides, so that will give me a positive 6400. Divide by 3 on both sides. X is approximately 2,133. So that's going to be my horizontal distance. So now I need to know where's the vertical. How high is it going to go when it's at 2133? So I have to substitute that in for x in one of these equations. I'm going to substitute it into this one up here. So to do that, I have y equals a negative. I have 2133. I need to square it. Divided by 1600 plus 2 times 2133. And that's going to give me the approximate vertical path distance. So I'm going to grab my calculator here. And we're going to plug everything in here. So turn it on, clear this here. So I have a negative on the outside, parentheses 2133, and I need to square that. This is going to be divided by 1600, and then I need to add 2 times 2133. That's going to give me an answer of 1422.444375. So they're saying the approximate, so we would round that to the nearest foot. This would be about 1422. So about 1422 feet. This would be the approximate height that our two graphs would intersect. You may do this next one yourself for extra practice. And your assignment for next time, lesson 112, numbers 1 and 2, 5 through 7, 10 through 11, 14, 19 to 20.